Welcome back, welcome back, welcome back. I'm Lisa Blackburn. This is my YouTube channel where we talk about everything I want to, science and math. And today we are continuing the notes with atoms in the periodic table. So you can go to Canvas and print them out, fill them in as we're talking about it. Where we stopped last time is we were talking about models of the atom, and we had talked about Dalton. He was a Quaker pastor, and he figured out the atomic theory of matter, that everything's made out of atoms. He didn't have it exactly right, but he was close, because what he didn't know was about subatomic particles. He didn't know the atom was anything on the inside, just the atom. But he was really close, and remember we talked about that that's why it's a theory, because it's changing. It's true. The theories in science are true. They're different than the common everyday language, and that's what we talked about yesterday. Okay, so then, you know, a lot of times in science, technology gets ahead of understanding it. So they had made a ray gun. How cool is that? And of course, what you do when you make a new gun, you shoot stuff with it, right? So they're shooting stuff with their ray gun. They all know what it is. They had sort of figured out a little bit about subatomic particles because of Benjamin Franklin, electricity, the kite, all of that. Benjamin Franklin really was like the pioneer scientist in that. So very famous guy for a lot of reasons. So they started figuring out that they had their ray gun, and they figured out that if they held a magnet up to it, that it would either attract the ray, sort of imagine a laser, or push it away. So they realized that there was a positive and negative part to the atom. They knew atoms were neutral, so they knew that there must be a positive part and a negative part, and Franklin had figured out the electricity, this negative energy, static electricity. They were figuring all of that out. So he had an idea that there was more to the atom than the billiard ball, J.J. Thomson. So he said that it's like plum pudding. Now, this was a long time ago, because that is not a real popular dessert anymore, is it? You can't get up for your dessert at Applebee's after you eat. I'd like some plum pudding, please. But that's why we got the Jell-O plum, okay? So what he said it was like is the drawing up here, that it would be like a big bowl of vanilla pudding with raisins in it. The pudding would be the positive part, and the raisins would be the electrons, the negative part, okay? So this was his model. It was based on, they had discovered the cathode ray tube, which was like a ray gun. The plums were negative charged electrons, and the pudding is positively charged goo. So they thought they had it figured out. Do you think they were right? Do we learn much about the plum pudding model of the atom now? No, they weren't right. So he had a friend, Ernest Rutherford, and Ernest Rutherford was going to prove his friend JJ was right. And so what he did is he set up this experiment, and they took foil made out of gold. Remember in our video, Adam's Ring of Truth, where there were the gold beaters, and they beat the gold until it was so thin they'd blow on it and it would shake? Remember that in our video? So he took one of those super, super thin pieces of gold. It's like aluminum foil, but much thinner. And he put it in the middle of this apparatus. He got his ray gun to shoot the gold with, and then he put glow-in-the-dark stuff all around it. Whenever the ray gun hits the glow-in-the-dark wall, it lights up. So what he expected, imagine if you shoot a bowl of pudding. What's the wall behind the bowl of pudding going to look like?
Like it has pudding on it.
Big old splat of pudding, right? So they thought they were going to get a big old splat of glow-in-the-dark back here somewhere. He was so confident that his buddy JJ was right, he didn't even show up at the experiment, but made his graduate students do it, because he didn't want to have to stand in the dark in the room looking for the glow-in-the-dark flashes. That sounded like a boring afternoon. He was going to skip it and go do something else. Turns out that's not what happened at all. 99.9% of all of the ray went straight through and hit the same exact part on the glow-in-the-dark. We have somebody here. Oh. We're doing the notes. You can watch a video of what you did. It'll be on YouTube later. All right. So it kept hitting the same spot over and over again. Every now and then, it would get deflected, and some would even come almost straight back at him. This was called the gold foil experiment, and he said it was shocking. He said he could not have been more surprised if he had taken a piece of tissue paper and shot a gun at it and it come back and kill him. Okay, maybe he was being a little dramatic. Are you shocked as he was by these results? Are you just absolutely shocked? No, because you don't understand it. This is why. What he found out is that the atom is mostly empty space. 99.9% of the particles went straight through. So the atom is empty. If this room were an atom, the nucleus, the only part that has any mass, would be a printed dot on your paper. If the atom were a stadium, it would be the nucleus, the only part with any mass, would be a baseball in the center of the stadium. The only thing that stops this hand from passing right through that one is not matter, it's energy. You are empty space. There's nothing there. Everything you touch is empty space. Now, are you a little shocked by the experiment?
Yes.
So, but you always knew there was more to you than the matter that makes you up, right? You're more than matter, so don't let this chemistry lecture devastate you or anything. So what he came up with is he said, there's these repeats in nature, and maybe that it's kind of like nature and like how our solar system is mostly empty space, and it's got the sun and the little planets go around it. Maybe the atom's like that. So it was called the planetary model. And it's sort of like this, like the sun in the middle with the little electron planets orbiting around. And he figured out that the nucleus was positive because these alpha particles were positive. And they were being repelled. That's why they could go straight back, as they were being repelled. So that you will also see this one represented what I call the Jimmy Neutron model. You can remember that old show, Jimmy Neutron? Did y'all ever watch that in reruns? Y'all are probably too young for it. But see how they're all orbiting the nucleus? Okay, so why was it shocking? The atom is empty space. Of 100,000 to 1. He came up with the idea of a positively charged nucleus, and nucleus is Latin for little nut. It means there's a little positive nut in the middle of every atom, the nucleus. Okay. So then came along Niels Bohr, 1913. We're getting to more modern times. And he figured out that electrons can only hang out in certain energy levels. Capital E is the chemistry abbreviation for energy. And the electrons can jump between the levels, but only in certain amounts of energy called a quantum. Have you ever heard of quantum physics, quantum mechanics, a quantum leap? That's what it's talking about. These electrons jump between energy levels. So his model, Niels Bohr, looks like that. And you're going to learn on the test that we'll have next Thursday, you'll learn how to make Bohr models. We'll be doing that next week. Next came along, later on in the story, a group of scientists, Frederick Jollet, Irene Curie, and Chadwick. They were lab partners, and they figured out there was another subatomic particle that has the same size of a proton, but it's neutral, and it's called neutral. That's messy. But neutral, and it's called the neutron. It's because I started writing neutron. So the only electrons are so little, they really don't have mass. and we're going to learn more about that. They have a tiny bit, but it's so little it's insignificant. The only thing that really has mass in an atom is the protons and neutrons in the nucleus. And Irene Joliot Curie, her mom was the most famous scientist ever, Marie Curie, woman scientist ever, Marie Curie, and we're going to talk more about her later. Okay, so what about the new model? It's called the electron cloud model, quantum theory, the quantum model, and the main scientist that I don't know if we could say he's the main one. A scientist who was important in it was a guy named Heisenberg, who came up with something called the Heisenberg uncertainty principle. We're going to do a whole test on this idea later, so we're just going to touch on it right now. But this is the modern view, and it's that electrons have a dual nature. They can be thought of as a particle or a wave. They can be a particle or a wave. So like, you know how electrons are electricity. So imagine electrons going through the wire, and then they hit the tungsten filament. Did somebody do their report on tungsten? And then they say, Shazam! I'm sure they do. And they can go flying off as a photon of light. So they can be a particle going through the wire, or they can be Shazam and fly off as a wave, as a photon. Now that's oversimplifying it, but it can kind of get the idea in your head. So there's a relationship between electron energy and light. And we learned that in our Atoms Ring of Truth video. Remember when we go whoop, whoop, and there was the light energy being given off by the elements in there? Now, when I say light, I don't just mean Roy G. Biv, the visible. I mean the whole light spectrum, the whole electromagnetic spectrum. And how you can remember it is this. Ronald McDonald is very ugly, extra gross. I don't like clowns. What can I say? So Ronald stands for radio waves. Radio waves are a kind of light. That's why you can hear the radio station in Atlanta instantly here. It doesn't travel at the speed of sound. It travels at the speed of light. Okay. The next one is microwaves. Is infrared, and V is visible, U is UV light, extra is X-rays, and gross is gamma rays. What turns Bruce Banner into the Hulk? Gamma rays. All right, so that's the whole light spectrum, and there's a relationship between light and electrons. How do we remember what is visible? What's the order of the rainbow? Roy G. Biv. Y'all know that? Yeah. Do you want me to sing the song? I'm going to sing anyway. Roy G. Biv is a colorful man at the rainbow's end. Do y'all know that song? It's from They Might Be Giants. You might have heard it when you were a kid. A band from the 80s. All right, so with the electron cloud model, they hop up the levels like they did with the Bohr model, but they also hang out in clouds where they'll probably be found. And the clouds aren't just in nice little circles. Some of them look like pluses, some look fuzzy, some look like baby pacifiers stuck together. They've got more shapes. And we'll learn more about that. We'll do a whole test on just that. Let's find our little button here. Where's the button? There it is. Okay. All right, now that was the story of the atom. Let's talk about the periodic table. The periodic table was discovered. It was not invented. There was a guy named, he was Russian, Dmitry Mendeleev, and he figured out that there were repeating predictable patterns if you arrange the elements correctly. Now, remember how we talked about like a lot of these people who started these different branches of scientists, they were ministers, they were monks. Dmitry, not so much. He was a graduate student, and he was in Russia. He liked to go to the bar, he liked to drink the vodka, he liked to play the cards. And he took his playing cards and he wrote down and stuck it to them all that was known about the elements, and he'd take it to the bar and he'd rearrange them until he started finding these patterns. He did it so great, he figured out that there were elements that had not yet been discovered, and he said they'll be discovered and this will be their characteristics. It was like he was psychic, and because then they discovered them. Now, he arranged it by atomic weight, what we would call nowadays mass, because they didn't know about the proton then, the atomic number. So he discovered the periodic table. Did I say he invented it? No, the patterns were already there. He discovered the patterns. So there's a song about it. We're going to sing it. Okay, this is how it goes. So remember, it was in the 1800s. He liked to go to the bar, and back then they would sing and do their cups around. It's what you did at the bar back in the 1800s. I don't go to bars, so I don't know if they still do that or not. Maybe so. Okay, so there's a song. Who told the elements where to go? Mendeleev. Who put them down in columns and in rows? Mendeleev. This is the touching part. Who was willing, who was able to make a periodic table? Who told the elements where to go? Y'all are really lame on your part. Let's try it again. One more time. Y'all got to do better if we're going to move on. Now remember, you can pretend you're a cup around and stuff like that too. This is the bar song. One more time. Who told the elements where to go? One more time. Who told the elements where to go? Who put them down in columns and in rows? Mendeleev. Who was willing, who was able to make a periodic table? Who told the elements where to go? Mendeleev. Now on the test, you're going to remember that. This is on the test, and you're going to say, who told the elements where to go? Mendeleev. And you'll be glad I sang you the song. Okay, so then came along Henry Moseley. He was it was at the time right before World War I. He was British and he was brilliant. Supposedly, he's the smartest person who ever lived. Smarter than Einstein, smarter than anybody. Bill Nye the Science Guy, smarter than everybody. And he figured out that Mendeleev had it wrong, that it needed to be arranged by the atomic number. The atomic number is the whole number that tells you how many protons there are on the periodic table. So he rearranged it. Now, he was young, he was in college, we have pictures of him, he was good looking. He was brilliant. World War I started and he got drafted. All his professors were like, no, this is the smartest person ever. He's smarter than us. Don't send him to the war. So what do you think the government did? Send him to the war, to the front line. He was killed. So England passed a new law. If you are a brilliant scientist, you do not have to go to the war. If you get drafted, you just get to go do science somewhere and try to win the war through science. But it's really sad. I mean, he died at 25, 28, something like that. There's Mendeleev's playing cards.
How did the government feel about it?
They felt real bad afterwards, once it was too late and he was dead. Made a law. So it makes me mad. They should have known better than that. The science brain is a natural resource that you should take pride in as a country. Okay, now the third part of it, Glenn Seaborg, he was alive, I know, in the early 2000s. He might still be alive. He rearranged it, and he pulled out the bottom section. You know how there's that part on the bottom? That's got too many humps on the end. He pulled that out. Now, we only have a little bit of time left, and I want you to be able to do your homework. So we're going to skip down. We'll save the story of radioactivity. I want you to skip to the part where there's this little chart here. Okay? Well, we might need to go up here. Let's go back here. Okay, so the atom is made out of protons that are positive, neutrons that are neutral, and you can remember that because protons start with a P, and positive starts with a P, neutral starts with the N, and neutrons start with the N. And then electrons are negative. Now this is the confusing part because negative also starts with the N, but this is how you overcome it. If you make a lowercase e, It almost looks like a negative sign in a circle. You got that? So electrons are very small, they spin. There's also some more subatomic particles called quarks. Okay, so this is your homework that you're going to be doing tomorrow. The last sheet of notes is a worksheet, but I'm going to show you how to do it here in your notes. Go down to your notes there. And also get that worksheet out and look at it. We'll be doing the first ones together. The worksheet that says atoms, that right there. Dajae has it. Hold it up high so everybody can see what they're looking for. Okay, so we're going to do this together. All right, so for each element, you can figure out its symbol, the name, number of protons, number of neutrons, its mass, whether it's an atom or an ion. So let's look at number 1, hydrogen. The symbol for hydrogen is H. Now, my list is in a little bit different order than your chart, but it's the same thing, just might be a different place. The name is hydrogen. The number off the periodic table, that whole number is 1. So its atomic number is 1. Its protons is 1. And if it doesn't have a plus or minus on it, the number of electrons is 1. So you can just fill all of those in. It comes from the number off the periodic table, the one that's not a decimal. Okay? The number of neutrons, how you get that is you look at the mass on the periodic table and you subtract the protons and round it off. So on the periodic table, the mass of hydrogen is 1. 1 minus 1 is 0, so the number of neutrons is 0. How you get the atomic mass is you add the protons and the neutrons. See where it says P plus N? And 1 plus 0 is 1. It doesn't have a charge, so it's an atom and the charge is 0. Let's try the next one. For the next one, they tell us the symbol is C. So what's the name? What?
Carbon.
Carbon. So you could write carbon. What is the atomic number of carbon off the periodic table? Shouldn't have taken your periodic tables up yet. If you look at it, it's number 6. The whole number is 6. So the protons are 6, the number is 6, and the electrons is 6. Does it have a plus or minus on it? No. So it is an atom with a charge of 0. Now, to get the neutrons, we have to look at the mass on the periodic table. It's 12 point something. If we round off, so we're going to write down that it's 12. We're going to round it off. And then to get the neutrons, we do the mass minus the protons. What is 12 minus 6? 6. Okay, let's try the next one. On the periodic table, if y'all had one, you would look at and find number 13 is aluminum. So we go from number 13 is aluminum. We write Al and aluminum. Okay, so if it's numbers 13, its protons are 13 and its electrons are 13. It has no charge. It's an atom with no charge. We look on the periodic table and its mass is 26.9. So we're going to write 27. What's 27 minus 13? 27 minus 13? 14. Okay, let's try the next one. Number 16 on the periodic table. We go find it. It's sulfur. So we're going to write sulfur and an S. It's number of protons 16, number 16. Oops, its electrons is 18. Oh no, they're different. There's more electrons, 2 more. Electrons are negative, so it's going to have a charge of minus 2. It is not an atom anymore. If it's charged, it's an ion. We need to write a little minus 2 over there, and now we can go on. The mass is 32. Let me make sure I'm right. Yep, 32. And what is 32 minus 16? 16. Do you sort of understand it?
Yeah.
There are instructions on the back and front of the worksheet too. So helium is number 2. We write a 2 for the number. The number of protons is 2. The electrons is 2. There is no charge, so it's an atom and 0. Helium's mass is 4, So its neutrons is 4 minus 2, which is 2. All right, so that's your homework, plus you're going to watch a video about the scientist. So that's your digital. All right, see you next time. Science is great.